Good morning, class. It is a new week. I hope you enjoyed your weekend. We want to continue from where we left last week. We had left when we introduced algebraic expressions and did a few exercises here and there. Today we want to continue and look at parts of algebra for purposes of solving mathematical problems, because we cannot solve mathematical problems if we don't understand parts of algebraic expressions. So to start with, let's look at a small exercise, exercise 3a, which will just introduce us to parts of algebraic expression. And today here I've lined a small exercise which we want to look at together so that we see what is algebra. If you look at this particular exercise, we are asked in question A, that question 1, fill in the missing words in the sentences using these words. The words that we have been given in this particular exercise are expression, term, constant term, and coefficient. So we are told to use these particular terms to fill in the missing words in the statements. Part A of the question is, and dash is made up of one or more terms. So the missing term here is an algebraic expression. An algebraic expression. An algebraic expression. An algebraic expression is made up of one or more terms. That is the correct statement. So we talk about expression, and we say an algebraic expression is made up of one or more terms connected by addition or subtraction. So an algebraic term expression is either connected by addition or subtraction. And we have seen in this particular example we have given, we have 2x plus 3y. This is an algebraic term, and this is also an algebraic term. They are connected by an additional term, which is this. So we read it as 2x plus 3y. We can also have another expression as 5r minus 7q. This is also an expression. Here we have 5r as an algebraic term, and 7q also as an algebraic term. And the connecting term here is a subtraction term, a minus term. So we read it as 5r minus 7q. Part B of the question, a term without a pronumeral part is, and remember from our previous lessons I had already introduced this, a term without a pronumeral part is just basically known as is a constant. It's just a constant. It is a constant. If it has no pronumeral, it will just be a number, so we just call it a constant. For example, we have said 2 is a constant, 3 can be a constant if it is in algebra, 10 can be a constant, 20 can be a constant, 100 can be a constant, 150 can be a constant. And we have said that also negative numbers And fractions are also constants. Negative numbers and fractions are constants. And we have given example of negative numbers. I can have -5, I can have -8, I can have -15, I can have -30, and so on. Provided it is a numeral, it will be known as a constant. Similarly, 2/3 is a constant, 9/20 is a constant, a half can be a constant, 5/6 can also be a constant, 3/2 is a constant, 5/3 is a constant, 7/4 is a constant. So these are examples of constants when they occur in algebraic expressions. So you can see that when we talk about a term without a pronumeral part in an algebra, it will be known as a constant. Let's look at number C in the exercise. A number multiplied by a pronumeral in a term is a dash. When we get a number, remember class what we said the other time, we had, let's say, a number 3 multiplied by a pronumeral. So this is 3, a number, this is a pronumeral. That is a pronumeral. So we have 3 multiplied by x. So this 3 multiplies x. This is a number. This is a pronumeral. And remember, in our introduction lesson, we say that if this is a number and this is a pronumeral, then this number is called in mathematics as coefficient. That is the lesson we had last week. We introduced a number multiplying a pronumeral as a coefficient, and this is called pronumeral. So this number is multiplying this pronumeral so that we get 3x. So when it is 3x, then the first part is known as a coefficient. The second part, which is our algebraic part, is known as a pronumeral. So when we come to this question here, we have been asked a number multiplied by a pronumeral in a number, in a term, is a dash. So here we comfortably fill what we call a coefficient. Coefficient. So any number that multiplies a pronumeral in a term is known as a coefficient. So coefficients are just numbers. So examples can be e.g. 3 can be a coefficient, 5 can be a coefficient, -8 is a coefficient, 11 is a coefficient, 3/5 is a coefficient, -2/3 is a coefficient, and so on and so forth. So these are examples of coefficients in a term that multiplies a pronumeral. So when a number multiplied by a pronumeral in a term is known as a coefficient. Let's look at part D. So class, a number and pronumeral connected by multiplication and division form a dash. Let's look at an example. If we have 4, then we multiply that 4 by a pronumeral, let's say t. where I want to signify this one as multiplication, and sometimes we represent this one mathematically like that. 4 multiplied by t, this one we get as 40. In this particular expression, the first part is a number. It is a number. What we call in our algebraic expression as a coefficient. We call that number coefficient. Then this part t is our what we call pronumeral. That is our pronumeral. So when we multiply a number by a pronumeral, we have 2 terms here. So the whole of this combined, when we combine the whole of that, the whole of this is known as a term, algebraic term. So we get a number which is a coefficient, multiply by a pronumeral, we get an algebraic term. That is the meaning of algebraic term. Algebraic term, you get a pronumeral, you multiply by a coefficient to get algebraic term. So the missing term here, word here is term. Algebraic term. So examples of terms here will be so the examples of terms will be, if I have a half x, that is algebraic term, minus 5/9 t, that's algebraic term, because here our coefficient is negative 5/9, here coefficient is a half, and the pronumeral here is x, here the pronumeral is t. We can still have 100n, where 100 is our coefficient and n is our pronumeral. We can still have negative 50y, where our coefficient is negative 50 but our pronumeral is y. We can still have 20r, 20 is our coefficient, r is our pronumeral. So we are getting those ones as terms. And when we get a term, an algebraic term must have 2 parts, a coefficient and a pronumeral. That is what we call algebraic term. And let's look at an example in that. So we can now connect algebraic terms with the addition and subtraction terms. When we have addition and subtraction terms, we can now connect an algebra. We can now connect algebraic terms. We can now relate them by adding and subtracting. So like for example here we can connect all these using addition and subtraction. For example, So connecting algebraic terms. So here we connect them using addition and subtraction signs. For example, I can have a half x minus 5/9 t plus 100 n minus 50y, and the connecting sign must be the one that will guide the interpretation of the term we are using in that algebra. So here you can see we have a half x minus 5t, 5/90 plus 100n. This is positive. And then minus 50y. Then finally we can also have 20r. This is now an algebraic expression which is connected using addition and subtraction terms. So here we can now state the number of terms in this particular algebraic expression. We can state the number of terms. And the number of terms are basically the components of what we have defined, which forms a term here. So this term, a half, is an algebraic term. That is term number 1. Negative 5/90 is a term. 100n is another term. 50y is another term. 20r is also another term class. So you can see that the number of terms in algebraic expression depends on individual terms that are defined by a coefficient and a pronumeral. Remember, we say that an algebraic term is that term that is combined, that is found using a coefficient and a pronumeral. Here the coefficient is negative 5/9. The pronumeral is t. Coefficient is 100. Pronumeral is n. Coefficient is negative 50. Pronumeral is y. Coefficient is 20. Pronumeral is r. So here we can just count the number of terms. How many terms are there in this particular expression class? So let's count them. This is the first term. This is 1, 2, 3, 4, 5. So they are just basically 5 terms. Five terms. They are 5 terms. That is the number of terms in that particular expression. Let's look at another example. Consider the expression. So class, as you will remember what we have said in the previous lesson, when we have an algebraic term, we have two or more terms being connected by a multiplication or divisional term signs. For example, here we have xy. This is an algebraic expression because we have multiplied x by y. So it is an expression because by definition, any term that is connected by a multiplication or division in algebra is known as a term. So xy is a term. Please, I want you to take note of that, because if we don't appreciate that this is also an algebra, we will miss the point, because when we'll be coming to a point where we are substituting for the numerical values of algebraic expressions, then we will not understand that two pronumerals connected by a multiplication or a division sign is a algebra. So the first part is a term because it combined two pronumerals by way of multiplying. We can also combine two numerals by way of division. For example, I can have t divided by r, which we can write as t over r. That is also algebraic term. This is an algebraic term. Why? We are dividing t by r to get t over r. That is an algebraic term. Now the second part is 4x, negative 4x. And here we have also learned that any algebraic term must be a term multiplied by a coefficient, which is negative 4, by a pronumeral x. Similarly, this is also a term. Why? We are multiplying a coefficient, which is 3, by the square of y. Remember, we have y multiplied by y, which is y squared. And that is also algebra because we don't know the numerical value of y. That's why it is called algebra. Finally, we have negative 2. Class, when we have a constant in an algebraic expression, it also qualifies to be called a term. A term is that part of algebra, two or more terms connected by addition or subtraction. So negative 2 also qualifies to be a term. So anything that exists in this particular expression is called a term, whether it has a pronumeral or it doesn't have a pronumeral. It qualifies to be called a term. And therefore, if that is the case, we are now able to state the number of terms in this particular expression, because this is term number 1, this is term number 2, this is term number 3, and this is term number 4. So there we have 4 terms. So the number of terms are 4. Why? We have explained that each component that is connected by addition or subtraction in an algebraic expression forms a term. So this is term number 1, term number 2, term number 3, and term number 4. So there are 4 terms in that particular expression. So let's look at the constant term here. The constant term in this particular expression is what, class? Remember we said that a constant term is that term in algebra which has got no pronumeral. It is not connected by any pronumeral. So if there is no pronumeral in it, then it is a constant. So class, what will be the constant in this particular expression? So the constant is -2. Why? It is the only term which is not connected by a pronumeral. So it is a constant because it has got no pure pronumeral. So a constant is that number which has no pronumeral. Let's look at coefficients. Coefficients of, so coefficients of these particular pronumerals. What is the coefficient of xy? It is a half. Why? Xy is divided by 2. So when we divide by 2, it's just like multiplying by a half. So a coefficient of xy is a half. How about coefficient of x? Class, we appreciate that the coefficient of x is -4. Why? This sign, this connecting sign is -4. So we'll say that the coefficient of x is -4. How about coefficient of y squared? Coefficient of y squared, class, is 3 because 3 is the multiplier of y squared. So these are the parts of an algebraic expression that we must appreciate, so that once we understand this, we are now ready to operate any algebraic expression, because we cannot avoid algebra in any mathematical field. Algebra forms a very important part of mathematical world, which is applicable in any field. You talk about geometry, you will find algebra. You talk about probability and statistics, you will find algebra. You talk about pure mathematics, you will find algebra. You talk about commercial mathematics, you will find algebra. So algebra is a branch of mathematics that find application across all the mathematical fields in the world. So that's why we want to understand it, so that when we'll be looking at a particular field and forming equations in the related equations, we'll be understanding what algebra is in explicit and implicit forms. So we want now, once we have understood the components of algebra, now we are ready now to move on. Now class, now we want to look at basic operations in algebra. We want to start with the basic operations in algebra. Let us look at basic operations in algebra. So which of the above mathematical operations? We have addition, we have multiplication, we have division, and we have subtraction. So when we have those particular operative signs in algebra, the term that will match each of the above operations here when you talk about the sum, we talk about addition. We talk about addition because the sum is just, we are bringing two components together in terms of adding, like 2 plus 3. When we add 2 items plus 3 items, we get 5 items. So sum means you add. Now difference means we subtract. For example, if we have 5 minus 2, the difference between 5 and 2 is known as 3. It's we take away. I had 5 items, but I've taken away 2. So I remain with 3 items. That is the meaning of the difference. Less than also is symbolically just basically subtraction. But when we talk about less than, it means whatever we have is not sufficient with what we need. Less than means whatever I have is not sufficient with what I need. For example, if I want to buy a cloth, I want to buy a shirt, for example, $200. I want to buy a shirt which is equivalent to $200. In my pocket, I have $150. So you can see that I need $200, but what I have is $150. So I still require, I'll require now $50 more to satisfy my need of $200. So that's why we say, when we talk about less than, it means that what I have is not sufficient to satisfy my needs. So the deficit is now what we call less than. So I'll say that I have $50 less to purchase a shirt which is $200. So I have $50 less to purchase what I need. The shirt is $200. I have $150, but I don't have $50. So I have $50 less so that I am able to purchase a shirt which is $200. So when you talk about less than, we mean what I have is insufficient to what I need. So to get the deficit, I must bridge the gap by saying that whatever you have less what you need will be necessary for satisfying your want. So my want is $200. I have $150, so I'll still need $50 so that that particular want is satisfied. So less than is also satisfied by the condition set here as negative. Then more than. More than means I have in excess of what I need. I have in excess of what I need. For example, I have $300, but I only need to spend $220. So you can see, we can see that I have $300, but I only need to spend $220. It therefore means that I'll have what we call a surplus. And the surplus here will be $80 will be the what I'll remain with, because what I need to spend is far much less than what I have. So more than means you have in excess of what you need, or your wants. Your wants exceed, your wants are less than what you have. Like we can say we have a surplus of food. That means what we want to consume is less than what we have in the store. So that will be more than. So we can also look at an example. Can write it as three more than x. 3 more than x here means what I have is x, but I have 3 more in excess. So this statement is written as 3 more than x will be x plus 3, because in addition to what you have 3 more than. Let's look at another example. $12 more than t. 12 more than t means we have t as our original quantity, but now we are adding other 12 items. This is what will be called 12 more than t. So more than here is also means we add. Then we have the last two, product. Product means multiplication of 2 items. We multiply 2 items. For example, we can say product of 2 and 3. And when we talk about product of 2 and 3, basically we mean we multiply 2 by 3, which gives us 6. So we define 6 as a product of 2 and 3 is 6. Let's look at an example. Product of 8 and 10. We multiply 8 by 10, we get 80. So we conclude by saying that 80 is a product of 8 and 10. That is the meaning of the word product. So we can appreciate that product means multiplication. Finally, we have quotient. Quotient means division of two items, two or more items. When we divide two or more items, the result that we obtain is what we call a quotient. So, for example, if I have five divided by 5 here means we have which we can write as and we appreciate that the highest common factor between 5 and 5 is 5 itself. So because we are dividing 5 by 5, division of 5 by 5 will be 1 here. And division of 5 here will be 1. So we have 1 divided by 1, which gives us 1. So I want us to understand when we divide 5 by 5, we get 1. So what is this 1? So this one here is the one we call quotient. The result we obtain by dividing two numbers is known as a quotient. So when we divide two numbers, the result we obtain, that is what we call a quotient. So a quotient is the results obtained by dividing two numbers, two or more numbers, sorry. So we can make a conclusion by saying that The result we obtained by dividing two or more numbers is known as a quotient. So let's look at an example there. Twelve divided by 4. We write this one as. So the highest common factor between 12 and 4 is 4 itself, and therefore when we divide by 4 we get 1. When we divide 4 by 12 we get 3. This 3 is our quotient. Three is our quotient. So we can now appreciate that the results we obtain by dividing two or more numbers is known as a quotient. So this will give us now, here we divide. That is the meaning of these mathematical operations in an algebraic expression. Let's now look at examples on that. So here we appreciate that x is equal to 3. The pronumeral x has a numerical value 3 in each case that we are going to deal with here. So we have been told that we substitute. Substitution here means where there is the pronumeral x, we replace it with 3. Whenever there is a pronumeral x in that particular expression, we replace it with 3. So substitution means replacing with. So when we are told to substitute, we are just advised to replace with. So where there is the pronumeral x, we replace it with the numeral 3 whenever there is an expression. For example, in the first part, we have x plus 4. We are just basically required to replace x with 4. Sorry, x with 3. So we'll get 3 plus 4, and 3 plus 4 is 7. Similarly, 5x, this one means 5 multiplied by x. Remember, we say that this 5 is a coefficient and x is a pronumeral. So we are multiplying the two, so we are going to obtain, and 5 times 3 is 15. In this case, we have 8 minus x. Our x is 3. Eight minus 3 is 5. Here we have x squared, so we substitute. It is 3 squared, and by use of our calculators, 3 squared is equal to 9. Here we have 18 divided by x. We replace x by 3. we have 18 divided by 3. And the highest common factor between 18 and 3 is 3 itself. So it means 3 can divide completely 18. So division by 3, 3 divided by 3, we get 1. And 3 divided by 18, we get 6. The answer here is 6. That is substitution. So with that, we come to the end of our lesson today. When we meet next time, we want to look at multiplication of operation using signs in algebra before we can now form algebraic expressions that are more advanced than this. Thank you and good morning.